Hi, I'm Chris Teutsch, Forage Extension Specialist located at the University of Kentucky's Research and Education Center in Princeton. And I'm going to be talking to you about measuring forage quality tonight. There's three basic topics I want to cover. I want to talk just a little bit about what forage quality is, two about proper hay sampling, and three about interpreting the results of forage test analyses. So what is forage quality? There's lots of different terms that we use when we talk about forage quality. For example, crude protein, or total digestible nutrients, or in vitro true digestibility, or NDF digestibility, and the list goes on and on and on. Really, to me, what forage quality is the ability of a forage to produce a desired animal response, whether that's pounds of milk in the tank or average daily gain. Now, this is a pretty simple concept, but it's a really complex process. There's lots of different factors that go into animal performance. And what we're trying to do when we measure forage quality is ultimately predict that animal performance. And sometimes that does not work out as well as we think that it should. The point that I want you to take home from this slide is that even the best estimates are not perfect when it comes to forage quality analyses. So a good forage quality test starts with getting a uniform sample that represents the hay lot that you're going to be selling or feeding. That is absolutely paramount. If that sample is not representative of what you're selling or feeding, then the results of the analysis are not worth a whole lot. We want to sample each hay lot separately, and a hay lot would be a given cutting from a given field. So if we have, for example, field 1, cutting 1, that's one hay lot. Field 1, cutting 2 would be a second hay lot. Field 2, cutting 1 would be a third hay lot, and so on. So each hay lot needs to be sampled separately. We want to use a properly maintained probe to collect the samples, and that means a sharp probe because we want to cut through that bale, not push through that bale. And we want that probe to be about 18 inches in length. The other thing is if we're sampling bales that have been stored outside, there will be a layer of weathered material on the outside of the bale. We want to pull that away. That represents refusal. We don't want to include that in our forage sample. We want to collect at least 20 cores per hay lot. We want to sample round bales from the side and square bales from the end. And we want to submit the entire sample that we've taken. We don't want to try to subdivide that sample. If I would reach into this bag and grab part of that sample, I would get the big pieces of that forage. And what I would miss are the fines at the bottom of the bag. And that's where a lot of that nutrition in that sample is. So it's important that we don't subdivide samples. Allow the lab to grind that entire sample, and then they'll subdivide it once it is in a uniform particle size. We have a brand new hay sampling publication, AGR 257. You can find it online or go to your local extension office and they can print you out a copy there. We also have a new hay sampling video, and what's kind of unique about this video, which you can find on our KY Forage's YouTube channel, is that we go all the way from sampling to the final step of using those results to determine whether we need to supplement a given hay lot. It's about 12 minutes long. It's well worth your time to watch if you're interested in learning how to sample hay and how to interpret the results. So let's talk a little bit about interpretation now. And this is just an example of a forage test report. This happens to be from Dairy One, but a lot of the forage labs will have a similar report. Reports can be a little overwhelming. There's lots of things on a report, and if you've never looked at one and you're not sure what's going on, it's a good idea to get with your extension agent and let them help guide you through it the first time or two. So we want to talk a little bit about what we traditionally focus on in terms of forage testing, and these are very traditional tests. Acid detergent fiber and neutral detergent fiber, and this is what we call the Van Soest analyses. And then crude protein. And crude protein is an estimate of the protein in that forage. And we take total nitrogen in that forage sample and multiply it by 6.25 to come up with what we call crude protein. Now, it's important to remember whenever we talk about forage quality parameters or use these forage parameters to um, build rations upon, we always want to do it on a dry matter basis. So with these traditional forage measures, ADF and NDF and crude protein, we can use them to estimate energy and dry matter intake. And we'll talk more about that in a few slides. So I just wanted to show you what makes up neutral and acid detergent fiber and just state how each one of those are used when we talk about whether a forage is going to meet the nutritional requirements of an animal. So if this is our plant cell, we have a gray area around here, and that's the cell wall. Inside we have all the cell contents, and they're highly digestible. And then this cell wall here contains cellulose and hemicellulose and lignin and fiber-bound minerals and silica and so forth. So the first thing we do with this forage material is that we boil it in neutral detergent solution. And that gets rid of all these highly digestible cell contents and then the pectin in the cell wall. So that leaves us with what we call our neutral detergent fiber, which is made up of hemicellulose, cellulose, lignin, silica, fiber-bound minerals, and so on. We use neutral detergent fiber to give us an estimate of dry matter intake. And that's an important parameter. When we balance a ration, we need to know how much of that forage the animal is going to eat. So we try to estimate that dry matter intake. And I will stress that that estimate is crude when we just base it on neutral detergent fiber. So after we boil it in neutral detergent solution, we can take that neutral detergent fiber and boil it in acid detergent solution. And when we do that, we get rid of the hemicellulose. So what we have left then is cellulose, lignin, silica, and fiber-bound minerals. And that's what we call our acid detergent fiber, and that would be neutral detergent fiber minus hemicellulose. We use this to give us an estimate of digestibility of that forage and to calculate energy in that forage. So ADF is related to dry matter, NDF is related to dry matter intake, ADF is related to energy in the forage in this traditional analyses. All right, let's talk about a little bit non-traditional approach to forage quality, and that's actually looking at fiber digestibility. So the previous approach was all chemical based. An acid detergent and a neutral detergent solution were used. The non-traditional approach actually looks at fiber digestibility and then bases energy calculations and dry matter intake calculations on that fiber digestibility. So how do we get at fiber digestibility in forages? Well, we use rumen fluid from the animal, and we actually have animals that have been cannulated, and that's when we put a hole in the side of the animal and put a big rubber plug in there. And then that rumen fluid can be collected by pulling that plug out and putting a vessel inside the rumen of the animal to collect that fluid. And then the forage material can be placed in that rumen fluid, and the microbes can digest that forage material, and that's how we get an estimate of the fiber digestibility of that material. And the way we do that is we actually take that ground forage material and we put them in these little mesh bags. We seal these bags shut and then place them in this jar, and then fill the jar up with rumen fluid. And then we take this jar, put it in this incubator that keeps it at a constant temperature and rotates these bottles slowly for 30 or 48 hours. And then after we're done, we measure how much of the material was digested by the microbes in the rumen fluid. It's not quite that simple, but that's the general gist of determining fiber digestibility. Now, one thing I'll say about this, as you can probably tell, this is very time and labor intensive. and it would be almost impossible to analyze all the forage samples in the United States using this method. And that's kind of where near-infrared spectroscopy comes in. This is a rapid, non-destructive analysis that's based on wet chemistry. So we do wet chemistry and then we build a correlation equation related to fiber digestibility. This is both accurate and precise. About 80% of the samples analyzed for forage quality in the United States are analyzed with near-infrared spectroscopy. All right, so we've got our numbers now. We're going to talk about estimating total digestible nutrients with the traditional numbers and with the non-traditional numbers. So if we look at total digestible nutrients and estimating them with acid detergent fiber, this is an equation. This was actually from Virginia Tech for grasses, and it is a fairly simple equation. It's based on ADF. We put it in and we can calculate total digestible nutrients. There's lots of different equations that are ATF based, and there's quite a bit of range in the TDN values that they output. So we could have the same acid detergent fiber, but a fairly different total digestible nutrients based on the equation that we're using. We use the traditional parameters such as ADF to calculate what we call a relative feed value also. And we'll talk more about using relative feed value and relative forage quality in a minute. Okay, if we take a look at this equation here, this is used to estimate total digestible nutrients with what we call the summative equation. So this equation takes into account the fiber digestibility of that forage. It's much more complex to calculate, but it gives us a better estimate of the actual energy in that forage material. And we use this summative TDN to calculate relative forage quality. I just want to tell you a little bit about a study that we did this summer at the research station, and it was a bale density and storage study. And we're going to use the data from this study to look at different approaches to estimating dry matter intake and total digestible nutrients. So it was conducted in Princeton. We had a random complete block design with 4 replications. We had a low, medium, and high density bales stored either inside or outside. We weighed, measured, and sampled the bales for nutritive value. It was 72 total bales, and each bale was sampled twice at baling and then again at feed out. We're not going to talk about the results from the study today per se, but we're going to use that data set to look at different methods for estimating total digestible nutrients and dry matter intake. We evaluated the nutritive value of this forage material using the near-infrared spectrophotometer in a very robust equation from the NRS consortium for grasses. And this is a comparison of the total digestible nutrients either calculated with the traditional method based on ADF or the summative equation. And I'll just point out here, here's a summary statistics for crude protein, neutral detergent fiber, acid detergent fiber, in vitro true dry matter digestibility, and then our 3 TDN methods. And we calculated the minimum value, the maximum value, median value, which is kind of like the average, but not impacted by extremes at either end, the average for the data set, and then the standard deviation. What we're going to focus on today is the average. And if we look at the 3 TDN equations, we've got ADF-based equation here, ADF-based equation here. We look at the results, we have 55 with one ADF-based equation, or 49 with a second ADF-based equation. The point that I want to make by showing you these 2 equations is that depending on the equation that we select, and again, there's a lot of different equations out there, the results can be quite different. It can vary by as much as 10 percentage points for total digestible nutrients. When we look at the 3rd equation, which is probably our best estimate of energy because it's based on the actual fiber digestibility of those grass hay samples, we have 58.2%, which is a little bit higher than our first ADF-based equation. All right, I want to talk just a little bit about estimating dry matter intake. Again, we need dry matter intake if we're going to balance a ration or really assess how much supplement we'll need to feed with the hay. In dry matter intake, based on our traditional measure of NDF, is a simple calculation. It's 120 divided by the neutral detergent fiber. And that gives us the dry matter intake as a percent of the body weight. Now, the second method is based on the summative TDN. Remember, that's the total digestible nutrients that were calculated based on fiber digestibility. This is a much more complex calculation, but it gives us a better estimate of what those animals will actually be able to eat. And I'm not going to go through this equation, but as you can see, it includes things like crude protein and ash and total digestible nutrients, ADF, and even fat to determine dry matter intake based as a percent of body weight. So when we look at dry matter as a percentage of body weight, and I've highlighted the boxes here I want you to look at, if we use a traditional method of just neutral detergent fiber, we estimate that that animal would be able to eat 1.7% of their body weight versus 2.15% if we use the summative equation. That's a big difference, right? So what the summative equation is telling us is that animal, based on fiber digestibility, can actually eat more of that forage than we would estimate just using neutral detergent fiber. And that's going to impact supplementation in that animal. If that animal can eat more, it's going to require less supplement. Okay, let's talk about a relative comparisons for forage quality. And there's two that we're going to look at: relative feed value and relative forage quality. Relative feed value has been used for a long time, and it compares forages to alfalfa at full bloom. So if it's 100, that means it's the same quality as alfalfa at full bloom. If it's higher, it means it's better than alfalfa at full bloom. If it's lower, it means it's worse than alfalfa at full bloom. We can use this to rank forages, make feeding decisions, and market forages. And this is how it's calculated. Essentially, it's dry matter intake times digestible dry matter. And these are both based on NDF and ADF, so traditional measures of forage quality. And then those two things divided by 1.29. And that gives us our relative feed value. So, again, this is based on traditional measures of forage quality. So our relative forage quality, again, compares to alfalfa at full bloom. We can use it, again, to rank forages, make feeding decisions or marketing decisions. And the equation is very similar, but the difference is that the total digestible nutrients used in this calculation and the dry matter intake are estimated based on fiber digestibility. So we're taking that forage material, putting it in actual rumen fluid, and letting the microbes digest that rumen fluid. The results are more representative of what actual animal performance will be. They're appropriate for all types of forages with the exception of corn silage. Relative feed value, the previous estimate, was really designed for alfalfa versus grass hay. Relative forage quality works much better when we rank grass hay. And that's what we see here. So when we look at this, and this is for that large hay sample set that was in the study at Princeton, if we estimate relative feed value, we come up with a value of 80, which means it would be considerably less than alfalfa at full bloom, versus 102, same exact forage, just use fiber digestibility to estimate the relative feed value. Last thing I want to mention is that whether you're buying or selling hay, it's always a good idea to have a good feel for how much your bales are actually weighing. Okay, in summary, get a good representative sample, estimate energy and dry matter using equations that include fiber digestibility, and use relative forage quality for feeding and marketing decisions. And the last thing, always weigh your hay. So I'll be happy to answer any questions if we have time. If we don't have time, I'll be on the end of the presentations tonight, and we'll save the questions for then. Thank you. Hope you have a great evening and enjoy the meeting.